In this video, we're going to see how to make transformations between delta configurations and Y configurations. The reason we want to do this is that sometimes it'll make it so that we can analyze a circuit that we couldn't analyze otherwise. So if it was in the one sort of topology, you would not be able to figure out information about it. But if you transform it, then you can. So what I have on the screen here are the formulas that you're going to want to use for making these transformations. Now I have these posted in the SI resources section. If you find the worksheet that says Y delta transformations, you have these posted, so you don't need to copy them off this video. What's important, or I don't know, it's the way I do them anyway, is to label your resistors when you do the problem. So you label them so that when you make the transformation, you'll know what goes with what. Now, this first one, this first box here, is showing a delta configuration on top. Both of these on top are delta. They may look a little different, but if you look on the one that looks more like a square, the bottom ends of these two resistors are just connected by a wire. You could slide them together to make a point, and then it would look just like a delta. And this thing that looks like a T is also the same as the Y. So I think they call this a pi configuration and that T, but they're really exactly the same. Now notice the way they're labeled is that resistor B is between nodes A and C. Resistor A is between nodes B and C, and resistor C is between nodes A and B. So the resistor letter is the one that's opposite from that resistor. If you remember, that's how we labeled triangles when we were doing trigonometry. The side is named for the vertex opposite it, and that's the same thing here. With the Y configuration, we use numbers instead of letters, and resistor 1 goes from A to the center, resistor 2 goes from B to the center, and resistor 3 goes from C to the center. Now, of course, you could label them whatever you want. It doesn't, the label doesn't mean anything, but these labels will help you match it up with the formulas that we have here. So we're going to do, in this video, we're going to do two examples. On the supplemental worksheet that I posted, there are some more examples that you can go through, and I put the solutions on there as well. Okay, so here's a delta to Y. So we are supposed to find the current and power supplied by the 40-volt source in the circuit shown here. And you can see that clearly we have two deltas. We only have to change one of them, because if we change one of them, then we've changed this 25 ohm resistor, and so then we've changed both of them. It doesn't matter which one we choose, and I believe I'm going to choose the top one just because that's what I have in my notes. So yes, so that is what I'm going to do. And so, okay, so I'm going to label these. I'm going to label this one RA, and I'll label this one RB, and I'll label this one RC. There's no significance to those labels other than the fact that they match what I have in my notes, so I can try to avoid making mistakes. So that means this is node C, because it's opposite RC, and this is node A, because it's opposite RA, and this is node B, because it's opposite RB. So there's my delta right there. And now let's go back and take a look at our formulas here. Okay, so, and I'm going to go ahead and draw what our circuit will look like. Actually, what I'm going to do is, this is going to look a little weird. I'm going to draw what the Y circuit is going to look like inside this delta circuit right here, and then we're going to erase the delta circuit when we redraw it. So it's going to go like this. Actually, let me see if I can make this bigger. Oh, that was not useful. Okay. Okay, so this will be my center. Okay, now let's go back and look at our pictures here. And notice that we have A, B, and C. A, B, C. Those still match up with where A, B, and C were on the delta, which is why I'm drawing it this way. So I still have the A, B, and C. And then notice R1 goes to A, R2 goes to B, and R3 goes to C. So this one will be R1, this one will be R2, and this one will be R3. Okay, so now we can compute these. So R1 equals RB times RC. So RB was 100. RC is 125 over RA plus RB plus RC. So that's 100 plus 125 plus 25. And that equals 12500 over 250. Which is 50, which, oh, you know, all of these I say, once I see, oh yeah, I should have known that, yeah, 50 ohms. Okay, so R1 is 50, now R2. Now notice you can also kind of remember these. 2 is like B, if you go A, B, C, 1, 2, 3, and B is the one that's missing from our top resistors in our formula. We have RC and RA, but not RB. So R2 equals RC, which is 125, times RA, which is 25, over, and the denominator is going to be the same for all of them, so that'll be 250. So we have 125 times 25. That was the numerator, divided by 250. That was the denominator, and that gets me 12.5. And then R3 is going to equal, so 3 is like C, so I will have not C in the top. I'll have RA and RB. and RA is 100, and RB is 100. I can't read my writing. RA is 25. No, that can't be right because I had that for number 1. RA is, yeah, that's right. Yeah, that's right. So RB is 100 and RA is 25 over 250. Well, just to make it match the order. RA is 25 and RB is 100. So that's 2500 over 250, and that better be 10 ohms. Okay, so now we have 10 ohms. So now we have changed that to a Y configuration, and now we can redraw our circuit, and what we do is we erase the old delta. So I'm going to erase these. And put in that Y. So I'll have black won't work on a black background. Oh, let's see. How about, let's do orange. Don't do orange that often. Okay, so I have a 40 volt voltage source. Then I have a 5 ohm resistor. And then I have R1, which I said was 50 ohms. And then I have R3, which I said was 10 ohms. And I have R2, which I said was 12.5 ohms. And then I have 40 ohms and 37.5 ohms. Okay, now let's see, what was the question actually asking us for? Current and power supplied by the 40 volt voltage source. So since we're just looking at the 40 volt voltage source, that's what we want. Our best bet is just to simplify everything over here into one resistor. So clearly the 10 ohm and the 40 ohm, those are in series, and the 12.5 and 37.5, those are also in series, so we can combine those. This is where I'm most likely to make arithmetic mistakes, and so if you see something that you think is not right, it might not be, but just hold on, I'll probably catch it later, and then we'll deal with it then. So I apologize for that. I can't really add. Adding is hard. Okay, so 10 plus 40, I think I can do that one, that's 50 ohms. 12.5 plus 37.5, I should be able to do that, but I do not trust myself. 12.5 plus 37.5 is also 50. For some reason I did not write down all the steps. That was foolish of me. Okay, so this is also 50 ohms. Okay, now we can see that we have the 50 ohm and the 50 ohm here, right here, the ones that were part of our delta configuration, those are in parallel. And when you have identical resistors in parallel, the equivalent resistance is half of the original resistance. So I can replace that 50 ohm those two 50 ohm resistors in parallel with one 25 ohm resistor. And this is 40 volts. Okay, so now $25 plus 50 is 75 plus 5 is 80. And again, what are we looking for? Current and power. Okay, so let's find the current. So now we have a simple circuit. We just have a voltage source and a resistor. So Ohm's law is all we need to get our current. So 40 equals I times 80, or I equals 0.5 amps. Alright, so that's current. Power equals IV, or 0.5 times our voltage, which is 40, or 20 watts. Okay, so that is transforming a delta to a Y. I think I'll do a separate video for Y to delta, so I'll stop this one here and make a new one for going from Y to delta.